On the screen as you walked in, it did say that I wanted you to try on this note sheet 3, 5, and 17. So we'll make sure we go over those. But I do want to do the teacher examples as well. This is helping us practice a skill from lesson 8 and 9. So we've been practicing this skill, but it was kind of rough. So we're struggling with the timesing, like 2 times x, things like that. We need more practice. So that's what today's additional lesson is. It's the same thing from 8 and 9, just a bit more directly, lots more examples and things like that. So this is going to be your note sheet. Remember, we don't necessarily always do the entire note sheet. You keep it for your binder check, so this will be included. I don't expect you to do all the problems on here. I just needed you to have some examples ready, and here they are. The skill that I need you to leave with is multiplying binomials. Do you guys know what binomials are? What are they? What does the prefix bi mean? 2. And then binomials are going to be 2-term expressions. If you want to fill that in. So that's like our main skill. There's some other skills on here, but the one I need you to leave with and have for the test is how to multiply 2-term expressions. So that's what this whole front side is. Most of the back side is a 2-term times a 2-term. We learned 3 different methods of solving them. One of them is foiling, and that's directly printed on your paper, and it has a diagram showing that you multiply the first, outer, inner, last. I think I'll show you that method when we do one of these later. But there was another method, where there's 2 actually. One of them was the box method, or diagram method, whatever you want to call it. And then the other one was double distributing. So I'll use these teacher examples to show you both of those. But the double distributing would look something like this. All right, in example 1, I'll show you that box method. But later, you can use whatever method you like us. But box method, the way that that gets set up is the terms from the same parentheses would have to be on the same side of the box. And you always keep the sign that's in front of each term. So this is a positive x and a positive 2. On this other side would be a positive x and positive 4. So if it was negative, make sure you have that negative control. In the boxes is you multiplying almost like the area. The dimensions of your box, you're multiplying them. So table 5, what's x times x? So that's what it'll go here. Table 6, what's x times 4? Table 7, what's x times 2? And table 8, what's 2 times 4? And that's me multiplying each term. This is a good way to organize it. But when we write our final answer in standard form, we want it to be fully simplified with all like terms combined. So does the x squared have a like term? So I just write it. I'm not combining the x squared with anything. Does this 4x have a like term? Yeah. What is its like term? The 2x. So that's what it means, like terms would have to be the same exact variable to the same exact exponent. These are both x to the first power. So you can combine them. Can't combine it with the x squared because it doesn't have the same exponent. What's 4x plus 2x? Table 1, can you tell me 4x plus 2x? 6x, and it's positive, so I'm going to put a plus sign. That's a common mistake I've been seeing, is there's not been putting a plus sign here. You need to, you got to show that it's adding 6x. And then this 8 doesn't have a like term, it's still in the answer. You're just not combining it with anything. And here's my final answer for example 1. Okay, questions on that one? That's the box method, if you like that method. Double distributing, I think makes the most sense to students. You guys seem to be able to distribute when it's just one term outside parentheses. Now you're just doing it twice, so that's what I'll show you with this one. So first I'm going to take my first term of the first parentheses and multiply it by both the terms in the other parentheses. So table 9, what's 2x times x? Right, so table 2 said it 2x squared. So then table 9, I'll give you another one. 2x times negative 5. Got it? 2x times negative 5. Okay, class, help them out. 2x times negative 5 is negative 10x. So 2 times negative 5 is negative 10. The x is still there. You just kind of attach it on. All right, table 9, redeem yourself. So I distributed the first term. That's me distributing. Now I need to distribute the second term. That's why we call it double distributing. So table 9, what's 1 times x? 1x, and it's positive, so I'm gonna put plus 1x. Table 3, what's 1 times negative 5? Negative 5. Then you check, it's not in standard form because I can still combine like terms. Usually it's your x term that you have to combine. Combine means you add them. And it's a negative 10x plus 1x. Table 4, what's negative 10x plus 1x? Good. Negative, show it that it's negative. Bring down the other terms that did not have like terms. And that's the final answer by double distributing. Questions on that method? I haven't shown you FOIL yet today. I plan to, maybe on the back side. But now that I just reviewed with you how this works, I do want answers for 3, 5, and 17 now. Those are the ones that we're reviewing on this page. I'll give you a couple more minutes to solve 3, 5, and 17. Can you like circle which ones I'm talking about so that I can play the announcements? 3, 5, and 17 are the ones I want you to. I'll be sure to go over those right after the announcement. All right, so whatever method you chose, you would have had these as final answers for 3 and 5, but I will explain both. And I'll show you number 3 using the FOIL method because I haven't done that yet today. So FOIL stands for first, outer, inner, last. That's the order that we're multiplying them. And that tends to actually still be the order we multiply them in the other methods. I like this method. That's all I learned in high school. They didn't teach the other methods. But I know for some people, it's hard to identify which is the first, which is the outer, and all of the things. So first would be referring to the first term in each parentheses. What's x times x? Okay, good, x squared. Outer means like toward the outside of the problem. So that would be you multiplying this x and this negative 4. What's x times negative 4? Good. Inner terms would be opposite of outer, so towards the middle. negative 10 times x is good, and then last would be the last term in each parentheses. So this negative 10 times this negative 4 gives me, what's negative 10 times negative 4? Positive 40. Show that it's positive. A negative times a negative gives you a positive. Usually you have to combine like terms, and it's usually these middle terms. Negative 4x plus a negative 10x is negative 14. So my final answer in standard form. So questions on that? No. The 40?
No. Are you adding?
So combine means add. You could look at it this way. Or you could look at it this way, which is still the same thing. So saying negative 4x minus 10x is the same as doing negative 4x plus negative. It's just that combine means add, so that's why I just put a plus. That's like, if you remember the warm up from yesterday, that's what we were trying to get you guys to see. Is that adding a negative is the same as subtracting. But it's adding that we're doing when we combine negatives. Questions on that part? Okay, good question. Now the next part. I'll show you FOIL again just because I have it here. But first term would be these two. 4x times x is 4x squared. Outer would be these two. 4x times 3 is a positive 12x. Inner terms, negative 7 times x, negative 7x. And last terms, negative 7 times 3 is negative 21. Remember, I've been seeing people make this mistake too. They're multiplying these, you add them, you combine like terms. 12 plus negative 7 is a positive 5. I think on that part. On the back, number 17, the other one I asked you to do. The reason I wanted to show you this one is because students will make a common mistake on this. They'll try to distribute the exponent. You can't do that. Remember what exponents tell you to do. What do exponents tell you to do? Multiply the base by itself, however many times that exponent is. So this time the base is this whole parentheses. So really your first step on this should have been to expand it to this. And then you could have FOILed, double distributed, box method from there. Okay. I will do double distributing. So that would be me taking my first term, multiplying it by both terms in the other parentheses. Table 4, what's 2m times 2m?
4m.
Close. What are we missing?
Oh, 2m squared. Or 4m squared.
Okay, good. And then table 5, 2m times negative 5. Okay, great. That's me distributing that first term. I need to go back and distribute the second term. And always keep the sign that's in front of each term. That is a negative 5 that we're multiplying by. Table 6, what's negative 5 times 2n? And table 6, what's negative 5 times negative 5? I think, I don't know what I said, but I'll take it. Anyway, this is what I have. Then I combine like terms, my middle terms, negative 10m plus negative 10m is negative 1 again. That's what you would have had for 17. Good question? Okay, so this is just a note sheet. You don't have to go back and do more on this, I mean, it is good practice, I do have it posted in school if you want the other examples. But you also picked up this coloring activity. Okay, this is gonna count as a project in here, just so you know. And you are multiplying binomials. There are a couple for the end, like where it's a binomial times a trinomial. On those, you just can't FOIL. You can still do like a box method. It's just now you have to make up for there being 3 terms on one side and 2 on the other. You could still do double distributing, you just can't FOIL on those. But I'll let you try that in the coloring activity. So what you can see on your coloring activity is a bunch of problems to solve with whatever method you want. I'm grading you on work shown and accuracy for being able to multiply each one. The coloring part would be extra credit, and here's how the coloring works. But again, it's extra credit, so this part would be optional. I think I have another one. So when you get your answers, in this first set, it wants you to find the sum of your answers. So once you have your 2 trinomials, it wants you to then add them together and you'll get one of the answers that is down here. I know it's like half cut off on the way that it was copied. You can pull up the assignment and still review this document and see what the options are. That's only if you want to put it. Do you have to add them together and see which one will match?
I think it's.
Yes, I will leave it up, but, also in the second set, it says find the difference of your answers. What does difference mean? It means it's subtraction. So in this one, and if you ask me, I'll help you when you get to it, but that's like more not the focus today. I need you to be able to multiply. But when you get your answers, you can subtract them and see which color to now color that number. Okay, does that make sense? Any questions?
Okay, and I'm gonna stop and I'll find out what.
So whenever you get these answers, so I don't know what the answer is. Let me make something up over there. I don't know what the answer is, I don't want to do it for you. But once you get your answer, you're gonna subtract your answers from each other.
Oh, I see. I understand.
Okay, any questions? So I don't want to take too much of your time. You have like 40 minutes to work on it. Ask me questions as you go if you're confused. But the main point, like the minimum requirement, is that you multiply the binomials and show work. And some form of work, any form of work would be acceptable. I think it does have it. Ron?